I want to show you what the packets really look like if you're doing a ping sweep. Actually, we're going to do a couple of different ping sweeps. We're going to use computers in my lab. Now, I've got my lab set up. Currently, there are 3 different networks inside. We're going to use a couple of them. And I'm going to remote desktop into these computers. This is a computer on the 192.168.7 network. It's a 7101. Now, obviously, this is a private IP range. And we're going to use this as the scan, the machine that's running the sniffer and the machine that's actually doing the ping sweep. And first, I'll set this up to scan the local network. So I'm going to scan the 192.168.7 network from IP number 1 up to through 254. And there's, I don't know, 5, 6 machines on this network. So before I do this, I'm going to start a new capture here. I've been playing around with this, trying various things to make sure this works. And seems like there's always something that goes wrong. Something that I can usually explain, but it might be confusing to you. So we got our capture started. Now I'm going to do our sweep here. And notice I've got this set up. Super Scan is only pinging. So I think those are all the computers it's going to find that are answering pings. So let's stop the capture and look and see what happened here. Let's start with packet number 2. Number 1 is a Microsoft networking packet. You'll see a lot of these, and for our purposes, we're not interested in these at all. And that particular one right there, 799 is the printer, so it's talking to one of the other computers here. Don't worry about those. Let's look at this. This is the start of our ping sweep. So this is the computer 7.101 that we're using as both the machine that's doing the ping sweep, and this is also where we're running our sniffer at Wireshark. So keep those 2 things in mind. So the first address we're going to ping is 7.1, and this happens to be the gateway. So there's the echo request or the ping packet, and we get a response. Okay, so now let's go down to packet 5 here. So in this case, this is an ARP broadcast, and what the packet's really doing, and this is what Wireshark translates this for us. This is actually not in the packet, but Wireshark's telling us what it's doing. This packet is asking who has or who's currently using the IP address 192.168.7.2, and for whoever is using this, whatever machine is using this, to tell 192.168.7.101, which again is the computer that's actually doing the ping sweep. We need this a reply to this packet so we can get the MAC address that we're going to actually use to address the echo request packet. We didn't need this for this packet here because this is the gateway to this network, and the fact that I'm remotely connected to it means that this number is in the ARP cache on this computer. So it didn't need to do an ARP broadcast. It had to for .2 because it wasn't in the cache, and there's no reply here, by the way. Same thing for 3, 4, 5, and on down the line. So if you're running the sniffer on the same network as the computer that's doing the ping sweep, you're going to see these broadcast packets, even if you're on a switch network, because they're broadcast packets. They'll go out all the different ports, and this is a switched network that I'm on here. So that's why we see all these ARP packets. We're on the same network. So the computer itself that's running the ping sweep is responsible for addressing the packets directly, and to do that it needs to do an ARP broadcast. And here we get a reply here, who has 7.90, and notice this is the ARP request, this is the ARP reply, and now we have the information here. This is the MAC address that's actually used as the destination right there to get this packet to 192.168.7.90. So in this case we get all 4 packets: ARP request, ARP reply, ping request, ping reply. But again, we only see all of these because we're running the sniffer on the same we're running a sniffer, but we're pinging the computers on the same network as the machine that's doing the pinging. So you see all these ARP requests, these broadcast ARP requests, and these replies. 99 is the printer, so we get a reply from it. Now, so you'll see here on a network where a lot of machines aren't being used, you'll simply see these ARP broadcasts, and there's no reply to them. And this is interesting. I've actually sniffed on our college network several times and saw patterns like this, where it looks like there's some sort of ping sweep going on. Very suspicious, I thought. So now let's look at it from the other end, what it looks like. Well, what I mean by the other end, let's ping another network. And I'm going to set up SuperScan here, and we're going to ping the 107 network. So we're going to ping 107 from .7 network. And I'm not going to pull the trigger on that yet. I'm going to go set up the network. Now before I do, I'm going to make a little stop here. This is 192.168.107.1. This is it's a Microsoft 2003 server, but it has multiple network interface cards, or multiple network interfaces, and it's set up to do routing, and it does the routing internally in my lab. So this is the gateway for the 107 network, and I've got a command prompt box here open. So if you do an ARP-A, you can see what's in the ARP cache right now. And this has got all the interfaces. This is the 107 interface. So it knows about 107.45, 101, 104, and 204. And from the 7 network, it knows the printer, and it knows 101. We were just using that as the ping computer that was doing the pinging. And this is the public one that connects to the college network. It knows about a couple of computers here. What we want to do is we want to clear as much of this out as we can. And I'm going to do this with the -D and the asterisk. So that's delete. Let us see what we've got left. We pared it down quite a bit. Somehow or other it's still keeping 107.45 and 107.104. I got a feeling it's keeping 107.104 because I've actually got a remote desktop connection to that. I'm not sure what 45 is doing. And it could be it's been checking mail or something that created an entry. So somehow or other we got rid of 104. Now my point is here, it's hard to keep everything out of the ARP cache on the server. So if you're looking at the other end, sometimes you won't find something that you think should be there, and it's because for some reason or another that entry was in the ARP cache in the server already. And let's run it again and see if anything's popped up. See, now 104 is back. So just keep that in mind, because both these machines are on. So we've cleared out all we can. Going to minimize this. I'm going to continue on to 107, 104. And this, what I'm going to do here is I'm simply going to capture on this computer the results of the ping sweep that we're going to actually run from the other network. So let's go back to over here to 7.101. Notice I've changed this. I'm scanning. I'm going to run a ping sweep on the 107 network. Okay, pull the trigger on that. And shoot, I should have started that first. Well, we'll just do it in two pieces. Well, we can do it right now. I'm going to start a capture here. And I should have done this before I pulled the trigger on this. So we're ready. So now start it again. And it'll soon be done. Now, notice here on the, now that we're scanning, or excuse me, I keep saying scanning. Now we're running a ping sweep. Well, it's actually a form of scan. Now we're running a ping sweep against another network. Notice we don't see all the ARP requests like we did before. Now again, there's this one up here with the between the printer and the gateway. Who knows what's going on there? But if you go down through here, if from 7.101 to 107.2, all we see is the echo request packet. Now this computer, this IP number is not used, so we're not going to see a reply. But we see the ping packet going out to the gateway. If you actually check the MAC address here, you'll find out these packets are being sent to 192.168.7.1, which is the gateway for this network. And then that's one of the router interfaces. And then it'll be processed through the router and sent out a different interface. But we don't see the ARP packets now because we're scanning a different network. Now, if you want to see the ARP packets, we go over to the other network. Now, then you'll see them over. This is the one right here. We'll see them over here. Let me close this. So we're picking up a lot of traffic here. And you remember we ran two different scans, so in here somewhere there's going to be two. Well, here's one. Here's the second scan. And notice what this looks like. If you look this up, this is the gateway address on this network, and it's this particular ARP broadcast packet is asking who has 192.168.107.236. If you have that, tell 192.168.107.1, which is the gateway on this network. So on the remote network, if a ping sweep is happening, you see all these ARP broadcasts, and in this case they're consecutive because that's the way SuperScan does it. Other tools don't do them consecutively. They switch them. They jumble the order, which makes it a little bit harder to tell what's going on. But when you see something like this, a lot of ARPs, you should think, looks like some sort of ping sweeps going on here. Now, another thing to keep in mind here is we did this with the tool set fast, and therefore we got a lot of packets in a short, in a very matter of seconds. With SuperScan, you can turn down the the rate that the packets are generated. And in that case, there'll be, you might see this packet interspersed with a lot of other traffic, and maybe you miss it. Maybe you don't realize that, instead of doing a ping sweep of this network that took 5 seconds, somebody's doing a ping sweep of this network that could take 5 hours, or maybe even a couple of days. And it would be very easy to miss those packets. Here you actually see a reply. Well, this is actually the actual packet here, going to 104. Now, I'm thinking we don't see the reply here because I have to check. I'm pretty sure this is a Windows 90, or excuse me, Windows 7 box. I'm pretty sure it's set up to not reply. It's the Windows firewall. It's set up to not respond, but we see the packet because you recall this is one of the computers that was in the ARP table on the router. So the packet was actually sent out. We don't see the reply on this one. Let's look on down through here and see what else we got. See if 45 replied. I think it did. No, I don't see it there. Well, and we wouldn't. You always got to think about, okay, where am I at? Where am I sniffing? And what can I see? We're not going to see 45's response here on 104 because we're on a switch network. And the actual packet, the echo request packet from the router is a directed packet, so it'll only go out on one particular switch port, and so is the reply. So we're only going to see broadcasts and things that are directly addressed to the port that we're on, which is this one. So this is a switch network, so you have to think about what you can see at any point when you're running a sniffer. Or, in this case, well, Wireshark is a sniffer. So think about this. I wanted you to. There's several takeaways from this. Probably the big thing is you always got to keep in mind is, okay, hey, I'm running a sniffer here. What can I see? If you're on a switch network, you're always going to see the broadcast. Now, you may not see the response to the broadcast. So, for example, in this case, if you look back over on the network that was doing the actually running the ping sweep, Superscan thinks there's a computer at 204. Now, we didn't see that in our packet capture because we were sitting at 107.104, which it makes sense because the echo request packet and the echo reply packet from 204 were they happened on a different switch port. We can see them over here. And by the way, while we're thinking about it here, you notice that 107.104, which is where we were running Wireshark on the other network, we don't see a reply here. And I'm pretty sure it's because that by default on Windows 7, well, Windows Firewall, that echo requests are, they're simply dropped. There's no replies sent back. So what I want to do here, I wanted to look at like 204. So here you go. There's the request going out, and here's the reply coming back. Now, we couldn't see that on the other network because it was on a different switchboard. But it came back to this machine where Wireshark's running here, and we could see it on this end only because this is where we're also running the ping, the tool that's doing the actual ping sweep. So I wanted to show you the difference, and particularly if you see something like this. Let's go back over to this network. If you see a whole bunch of ARP broadcast request packets here, um, in all these cases, this is the, if you look this up, this is the gateway, the router interface that's, looking, trying to obtain the MAC addresses of these IP numbers, and it's because something triggered it from the outside. In this case, we ran a ping sweep from another network, sweeping this network, and it generated all these ARP broadcast packets. So if you see this, this tells me that there's some sort of sweep going on. Somebody's probably looking for live machines, and you'll see this very, very frequently on public networks. These succession of ARP packets. So think about the distinction between what it looks like if you're pinging your network, if you're pinging another network, and if you're thinking about what the packets really look like. You always got to ask yourself the question, where am I running the sniffer? Most networks these days are switched. You only get to see broadcasts and traffic that's in and out of your switch port. So that limits what you can see. Now, if you're going to run a sniffer or something like an intrusion detection system at the enterprise level, you need to be mindful of where you're going to put your sniffers at, so you can actually see the traffic that you want to see, and that's a whole different discussion there. So think about this. I think this is pretty interesting material, and this is the kind of stuff you should have learned in your introduction to networking classes, or the TCP class, TCP/IP class. This is how networks work, and when you see these type of packets, I want you to kind of have an idea of what's going on.